Hi, thanks, Kendra. We are here in the NASA News Center, and I'm here with Bob Bagdigian. He's a project manager out of the Marshall Space Flight Center who works the International Space Station Life Support Systems. And Bob, you're going to walk us through the not only what we have here, the oxygen generation system, which is already on board the station, but what we're bringing up on this mission.
That's correct. Collectively, we refer to this entire 3-rack system as a regenerative life support system. As its name implies, we use this to, through regenerative means, provide the crew with all the oxygen and water that they need. The oxygen system is on orbit right now. It was launched on STS-126 in July 2006. We've been putting it through periodic checkout since that time. Everything's looking good with that system. What the system does, it generates oxygen for the crew to breathe through a process of water electrolysis. It will get its water, ultimately, from the water recovery system.
We'll walk down here and take a look at that now.
This is what's flying. This is what's called our water recovery system. It's on the vehicle tonight. It'll be launched. And during the 126 mission, these 2 racks will be located out of the MPLM module and installed in the Destiny module, and will begin to go through a sequence of checkout procedures to make sure that this system is operating the way it's intended.
And there's 2 racks. They each serve different functions. We walk through. How about the first water recovery system rack?
Right. Both racks collectively include the water recovery system. There's 2 main parts of that system. A urine processor assembly, which, as its name implies, recovers urine through a process of distillation, and a water processor assembly that takes the output from the urine processor and mixes it with all the other wastewater we get from the crew, which is predominantly humidity condensate that comes from the crew's breathing and sweat, and puts that combined water through a sequence of treatment processes.
And how does it help us out? How does it filter all this stuff out?
Okay, well, let's take it one at a time. We treat the urine first through our urine processor. The heart of that processor is shown down here. It goes through what we call a distillation process. It basically turns that urine into steam, which is purified relative to the urine. It's separated from the urine through a artificial gravity force that's generated inside this rotating device. Okay. That steam is separated and then is combined with humidity condensate to go through the remainder of the treatment process. That treatment process includes particulate filtration, a sequence of chemical beds that we call multi-filtration beds, and these beds have materials that you can commonly find here on the Earth in water purification treatments systems for the home. Things like activated carbon and ion exchange resins. What we've specifically done here is arranged and selected those materials to treat the very unique type of wastewater that we have here. Once the water comes out of the multi-filtration beds, it's very clean, but still not quite clean enough to give to the crew to drink. And so we put it through a reactor ORU that heats that water to a very high temperature in the presence of a catalyst, and we can oxidize any trace organics that are residual in that water. Some final polishing beds remove any residual contaminants. We add iodine to the water to maintain microbial control during storage. And then the water is stored in tanks and is available to the crew to use whenever they have the need.
And the crew typically uses, we found on the station, about a gallon of water a day per person, give or take?
That's right. Roughly about 1 gallon a day. For a crew of 6, obviously, we'll need to provide the crew with 6 gallons a day. Now, there are a number of different ways that the crew can get water on the space station. During the initial operation of this system, as we're checking the system out, this system will be giving the crew about 2 of those 6 gallons. It has a higher capacity, so the program will have flexibility once this is checked out to put more reliance on this system for supplying that water.
And obviously this is just our initial steps at this regenerative life support systems. This is our first way of turning sweat and urine and wastewater into usable water, because we obviously can't take water runs to when we're on trips to the moon and on to farther away places like Mars.
Yeah, that's absolutely right. For the International Space Station, that's in low Earth orbit, obviously costly to get material to the space station. This system, with the performance efficiency we have in this system, can support the space station very well. But as we look ahead towards going to the moon and then to Mars, we understand that the efficiency that we expect to achieve in this system, we're going to have to do even better on. And by getting this system up and operational on the space station is going to give us a very important opportunity to gain long-term operational experience with systems like this, so we know where to target our future improvements for exploration beyond low Earth orbit.
And that's the idea, that the International Space Station is a test bed for these exact kind of hardwares, procedures, and they start out being refrigerator size, and the idea is that future versions should be smaller, more compact, easier to use.
That's right. We're always looking for ways to improve weight and volume, always at a premium. Power, reliability, especially when you're talking about a life support system, is high up on the list. And by running this kind of system for a long period of time, we'll get a lot of important knowledge about what things tend to wear out sooner than others, and where we need to apply some engineering and technology development resources.
Well, the crew plans to take samples that have already been provided by the International Space Station crew members, and they will run it through the system?
That's correct. The space station crew has already collected and set aside some urine. That urine will serve as the initial testing fluid for this system. Once the system is installed on orbit during this mission, it'll be activated. We're very anxious to go ahead and get this system up and running during this mission, so that the crew can collect some water samples, get them back to the ground on this mission, and we can begin gathering that data that we're going to need to finally declare next springtime that this system is operational and ready to support 6 crew.
Right. It'll take about 90 days or so and test the water. And,
right.
Well, one of the other things that beyond the obvious is, well, let's face it, we're talking about turning old water into new water, and you guys refer to it as the ick factor. And I'll be perfectly honest, that even people, not just media that we have here, but members of NASA, when they heard I was going to sample some of the water, I got it. Are you kidding? You're seriously going to do that? And that's a psychological thing you have to overcome.
Sure, and we fully expected that back in the earliest days when we were going about the conceiving a system like this. We got to the point where we had selected our technologies and tested it, and we knew we could put a whole bunch of laboratory data on the table with numbers that showing that the water is clean and safe, but we always knew that was going to be that subjective ick factor that was going to have to be overcome. So we actually went through tests with subjects and gave them blind samples of our water compared to similarly treated tap water and asked them to rate it. And we could never find any statistical meaningful difference in the rating of that water compared to other water.
Well, and it doesn't actually, and I'll say, this is actually a sample that you guys have collected from the fine folks at the Marshall Space Flight Center.
Yeah, some of me is in there, I think.
Well, I really didn't need to know that. It doesn't actually help when you have on the bottle it says we use only the finest ingredients: urine, perspiration, food vapors, bath water, simulated animal waste, and a touch of iodine.
Yeah, everything we could throw at it, we threw at it, and there it is. There's the product.
There it is. A little bit of urine. That's great. Well, with no disrespect to Mr. Armstrong, this is one small sip for me and one giant leap of faith for my mind.
Cheers.
Yes, at this time, I can give you KC area is clear for launch.
Actually, it doesn't taste any worse than the bottled water that I had the rest of the day. Although a little bit of you in there probably was more than I needed to know, and but it really wasn't that bad. And if it can produce that for the crew and save water, save money, and that's a good thing.
Absolutely, we're very excited. Looking forward to this having a long, useful life on station.
Excellent, Bob Bagdikian, thank you very much for joining us, and we're going to actually go back now to the Launch Control Center and Kandria Thomas for the rest of the countdown, and good start to a good mission. Kandria?